English with Astronomy, Episode 9.
From galaxies and stars, let's move to measurements. Serious observing means knowing how to pin down positions and time for different objects and events.
All right, let's go.
My final episode is called Longitude, Latitude, Time. To avoid getting lost on Earth, people long ago learned how to determine their location. For this, they developed geographic coordinates, latitude and longitude. Astronomers went further and created a similar system for the sky, so they could state exactly where a given star is on the celestial sphere. Imagine the Earth's axis extended into space and piercing the sky at 2 points. These are the north and south celestial poles. The celestial equator, like a giant ring, girdles the sky at right angles to this axis, dividing it into northern and southern hemispheres. The point directly overhead is called the zenith, and the plane perpendicular to the vertical defines the horizon, the boundary between the visible and invisible parts of the sky. On the horizon, there are 4 key points, without which it is hard to find your way on land or at sea: north, south, east, and west, the cardinal directions. The north point lies under the north celestial pole. Opposite it is the south point. East and west are a quarter of a circle from them. When the sun reaches its greatest height above the horizon, the shadow of a vertical object lies along the north-south line, called the noon line, the meridian. To mark a star's position in the sky, astronomers use 2 coordinates, declination and right ascension, just as we use latitude and longitude on Earth. Using these celestial coordinates, they make star charts, determine precise time, and find target stars among thousands of others. The need to measure time arose long before the need for celestial coordinates. Daily life was always tied to the alternation of day and night. In antiquity, the sun's position in the sky was the main timekeeper. People used it to orient themselves in both space and time. Nature itself provided the basic units: the day, the period of the Earth's rotation on its axis, and the year, the period of its orbit around the sun. Already in ancient Babylonia, the day was split into daytime and nighttime hours, 12 each. These hours were unequal and changed with the seasons. The year was divided into 12 lunar months of 29 to 30 days, with an extra month added from time to time. By day, time was measured by the length and direction of the shadow of a vertical stake called a gnomon. Such sundials worked only in clear weather and only during daylight. In Greece, people invented the water clock, the clepsydra, literally water thief. Later came hourglasses, still in use, and then mechanical clocks with a pendulum. Because the Earth's motions, the appearance of the starry sky changes over a day and over a year. Constellations are seen differently at different times and places, so people learn to navigate and to keep time by the stars. But a problem arose. Along different meridians, the time is different, and noon does not occur at the same moment. As travel connected distant places, trains and airplanes needed coordinated schedules. Therefore, by international agreement, the whole globe was nominally divided into 24 time zones. Within one zone, the time is the same. Crossing from west to east, you typically set your watch 1 hour forward, from east to west, 1 hour back. The 0 time zone is centered on the Greenwich meridian near London. Across the Pacific Ocean between Russia and Alaska runs the International Date Line. Crossing it from west to east takes you into yesterday, and going the other way puts you into tomorrow. Because the Earth does not rotate perfectly uniformly, the length of the day changes slowly. Modern atomic clocks help monitor these deviations and provide time signals that are broadcast by radio. In this way, humanity learned not only to find its path among the stars, but also to measure the flow of time with great precision. Your turn, Jim.
Thanks, Susie. Here are my 4 questions. First, what are the zenith and the horizon? Second, which 2 celestial coordinates do astronomers use, and what are their Earth analogs? Third, why did we need time zones? Fourth, why do we need atomic clocks today? And now, my version of the story. Look up and picture the sky as a mapped globe. Extend Earth's axis and you get the north and south celestial poles. Stretch the equator into space and you have the celestial equator. Over your head is the zenith. The edge of your world is the horizon. On that horizon, I steer by the 4 cardinal points. When the sun climbs to its highest, it crosses my north-south line, the meridian. That's true noon. To nail a star's position, I use declination and right ascension, the sky's latitude and longitude. With those, I can chart the heavens, tell precise time, and point a telescope like a pro. Timekeeping came first. 1 spin of Earth gave the day. 1 lap around the sun gave the year. The earliest clock was the sun itself. In Babylonia, day and night split into 12 unequal hours. Lunar months set the rhythm, and a gnommon's shadow marked the march of time. Later came water clocks, sand glasses, and pendulums. Because Earth's motions repaint the sky hourly and seasonally, people learned navigation and time by the stars. Local noon shifts with longitude, so the world settled on 24 time zones, zeroed at Greenwich. Cross the international date line near Alaska and Chukotka, and the calendar jumps. West to east, you step to yesterday. East to west, tomorrow. And since Earth's spin isn't perfectly steady, I trust atomic clocks to keep us honest. They track the tiniest drifts and broadcast standard time, so our measurements and our lives tick in sync with the universe.
Earth's rotation may be less than perfect, but tonight's sky looks close to it. So let's wrap the podcast, grab a telescope, and head out for some night observing.
Great plan, Susie. Friends, we wish you clear skies and rewarding observations. That's all for today. Bye.
Next time, I'll tell you about planets, comets, and other residents of the solar system. See you soon. Bye.